Dear students, greetings from Dr. T. Sindel Associate Professor and Head, Department of Information Technology, Kakatiya Institute of Technology and Science, Warangal. In this video lecture, we are going to discuss about one of the application of stack, like Tower of Hanoi. It is a puzzle game. It is generated by one German person. This game, how it is working, based on that, we have to write the program. Okay, so this is one of the stack application we will discuss in this video lecture about Tower of Hanoi. Dear students, this is week 5 lecture 2 classroom discussion topic 14 applications of stack. The Tower of Hanoi. Tower of Hanoi is one of the application of stack. So what is Tower of Hanoi? Before discussing about it, we must know the concept outcome of the particular lecture. After completion of this lecture, students will be able to develop a C program to perform regression operations using stack for multiple applications like Tower of Hanoi, Fibonacci series, factorial functions, like many things, many applications. So these are the applications of stack like parenthesis checker, reversing a list, conversions of expressions, evaluations of the expressions, recursive functions, and Tower of Hanoi. So now we are going to discuss about the Tower of Hanoi. What is Tower of Hanoi? So a French mathematician, Edard Lucas, invented a game puzzle called Tower of Hanoi in 1883. What is that puzzle? Its game is related to religious temple of Hanoi, okay, Vietnam. It is available in the Vietnam. The name of the temple was the Tower of Hanoi. This temple has 3 towers, which are surrounded by 64 golden discs in the temple. Okay. The temple priest used to pass these discs from one tower to another with the traditional rules. It is one of the temple is there. There is a 3 tower is there. There is a 64 discs are there. We have to move the disc from one to another. There is some rules and regulations is there for shifting that disc from one tower to another tower with the traditional methods. If all 64 discs are shifted, if the first disc is reached to the first position, means the world will be over. So that's why we are saying this is the Tower of Hanoi or Tower of Brahma puzzle. Okay, this is little story about Tower of Hanoi, but how it will be work in the stack. What is Tower of Hanoi? Okay, so it is one of the mathematical puzzle. It needs some stack to store the values for go back and use stack operation like push and pop. How it will work? Okay, that we are going to discuss about it. So if we want to discuss about it, we need some rules and regulations how we can play the Tower of Hanoi game. Okay, so what are the rules are there? First one, a person only has to move one disc into a middle towers at a specific period. Remember that only the top disk required to be removed. We can remove only top disk only. Third one, any larger disk can't be placed on the smaller disk. So don't keep larger disk on the smaller disk. These 3 conditions you have to follow. So these 3 towers are there. You can all the disks are there. Each disk have different size. So don't keep largest disk on the smallest disk. Okay, yellow color is the smallest disk, blue color is the largest disk. So you can always keep like this order only. So in top of the green you can keep yellow. In top of the blue you can keep other twos, but don't keep blue on any others. Okay, so this condition you have to follow. First condition, what is the first condition? Only one disk can be moved at a time. You can move only one disk at a time. Second condition, what is the second condition? Each move consists of taking the upper disk from the one of the tower and it will be placing on top of the another stack. So now we are going to stack concept. That is, a disk can only be moved if it is the uppermost disk on a stack. The node disk may be placed on the top of smaller disk. Okay, so you just see here, green, white, red color is there. So initially 3 towers are there. All 3 disks are in the tower A. So now what we have to do, we can move one disk at a time. First condition, I am moving red color. When I am moving, I have to check any smaller disk is there compared with this disk. No disks are there. Directly I can keep it. The second time, second it will be moved to the middle auxiliary tower. Okay. So this tower it will move because there is no smaller disk also. Now you can check the condition. Okay. So which is a smaller? If you are removing the green color, we unable to keep these two because these are smaller disk. So what we have to do? This red color will be moved to the white. Okay. So red color will be shifted to white. After shifting here, now the C tower is free. So now I can shift the green color to here. Okay. So now what happened? If in case I want to move red means again I unable to keep white. That's why red I will move to tower A. So now green is in the C tower, B is in the middle tower, and red color is in the tower A. So now I can shift white into the green. Then finally I can shift red into the white. So all the disks are shifted to the target position. Okay, this is a source, this is a target, it is the auxiliary. So like that we can fix and we can write the program. So this is a Tower of Hanoi program, you just consider. It's a simple program we can write like this. So initially we have 3 disks. Okay. So initially we have 3 rods, 3 disks are there. We have given the name ABC, sorry, ACB. Then we are passing this number of disks, how many disks you want to shift. Okay, so you will shift it here. This is the Tower of Hanoi function. Initially it will get the n value. It will take the from rod, to rod, auxiliary rod. Okay, so from rod is A, to rod is C, and auxiliary rod is B because we are past ACB here. Okay. So after getting this, it will check n equal to 1. N equal to 1 means only one disk is there. Directly we can move to the particular destination. Destination is C. Okay. 2 rod. So directly you can shift it to here. So if not means we can check n minus 1. We can change n minus 1. Then again we can change that value. We will give that same values to with n minus 1 function. This is a recursive function. Okay. This function call itself with n minus 1 value. Okay. So up to reach this value, it will be executed continuously. Okay. So this is a simple example. But with the help of stack, how it is working, that we will discuss now. Okay. So see here. So I am creating one structure as a stack. So already we know that stack means we'll create some like array like that. So in the top one pointer we are created unsigned capacity. Unsigned is the data type. Capacity we have to take. That is size of the stack, and we have to create one array pointer. Okay. So for this stack pointer, we can create stack using capacity. The function to create the stack of given capacity. So what are the function is there? Just to see here. So with this structure, I can assign the values for this stack tends to capacity. Okay. So we are creating one pointer. That pointer is pointing to the members of the structure. Okay, so stack of capacity equal to capacity. Initial condition, we are assigning initial value. Capacity is equal to stack capacity. Minus 1 means stack top is minus 1. So this first position is minus 1. So it's not first position. Actually, there is no element, means minus 1, null element. After that, we have to create the array. Okay, how much array you have to create? How many elements you are given, accordingly the memory will be created. Okay, this is one of the function. Create the stack. After creating, what are the function we have to check? The stack is full or not, we have to check. How we can check? Stack tends top equal to minus 1 or not. We are checking capacity minus 1 is equal. If both are equal means the stack is full. Stack is empty means stack times top equal to -1. So then stack is empty. So initially we have to check it is full or not, or it is empty or not. After checking that, we want to check this function, we have to call. Then we have to check if it is full, then we have to push operation. What push operation? We have to insert the element. Is full or not, we have to check. Is full means just return. We are unable to insert. If not means stack tends to array of plus plus stack. So stack pointer will be pointing to the next location of the created array. So there the value will be stored. Okay. So pop means again we have to check it's an empty stack or not. If it is empty means it will return the minimum value. Otherwise the array stack pointer top minus minus means top pointer will be reduced to next created array stack. To move disk, how we can move further? This is the important step. Move disk from which place to which place. Okay. So A to B or B to C or C to A, like that we can print it. Disk from or disk to. So those things we will print. This important things we have to check. Move disk between two poles. So what are the condition we have to check? Okay. So initially pole 1 top disk, pole 2 top disk. So both we will check which is the source, another one is the destination. Okay. So if what operation we are doing, if you want to remove means we have to do the pop operation. If you want to insert means insert operation. Where we have to take, we will take it from the source, we will keep it into the destination. Accordingly, we can create it. It is int minimum value. Int minimum means it is the empty or not we are checking. If it is empty means we have to push the values one by one. Source to pole to top disk. One value will be moved there. Move disk means what are the things? Move disk is a separate function. We will discuss later. For that, we are sending that destination value, source value, pole to top disk value. So when pole to pole is empty, so again pole to pole, second pole is empty means we have to check. If it is empty means then we have to send a destination to pole 1 top disk. That will be pushed into pole 2. Then move disk from source to destination, pole 1 top disk. So like that it will be shipped. What conditions we are checked in the previous examples with the diagrammatic representation, same it will check. Okay. So after checking that, Tower of Hanoi iterative, how this Tower of Hanoi is working. It will take structure stack source pointer, destination pointer, auxiliary pointer. With these three pointers, how it will be work, I already told. Okay. So the tower name is maybe JKL. We'll check number of disk modulus 2 if it is equal to 0. Then we can change that value. Okay. First we have to arrange in the order. Then only we can perform the operation one by one. Okay. So number of moves, it may be power of 2 comma number of disk. This function it will call how much number of disk we are used 2 comma 4 from that 2 power 4 minus 1. Okay, that is the number of moves. So we can call that function with the push operation source comma I value. How many disk is there initially? We have to insert one by one. Okay. So after inserting it, we have to check I modulus 3 equal to 1 because 3 pole is there. Based on that, we have to check. If it is remainder equal to 1 means it will go for source to destination SD. So the move from 2 pole. Okay. If modulus equal to 2, the remainder is 2 means move disk between 2 poles. Like which one is, first one is source to destination. Here source to auxiliary disk. If in case 0 means auxiliary to destination. Okay, we can check these values. Finally, we can call the function with create stack with the source pointer, auxiliary pointer, destination pointer. With number of disk, we can call that function. After call those functions, the tower of Hanoi function also called for perform those operations. Okay, so now we are in the reflections part. Using regression technique is reducing the memory space. True or false? Okay, so we must be know using the recursive concept for performing the tower of Hanoi problem. It will occupy more memory or not? That is the question. So you have to answer for that question. If you are answered properly, then we will proceed further. Otherwise, go back and watch the video once again. The given time is over now. 10-second time is over. I hope you understood it is true or false. So we know that when we are using recursive function, it will occupy the more space, but it is very less time. Based on the time complexity, it is advantage. Based on the space complexity, it is the disadvantage. Okay, it is false. It increase the space. So in these examples, we are discussed about what is Tower of Hanoi, how the Tower of Hanoi, history of Tower of Hanoi we discussed. Then how we can perform this Tower of Hanoi game. For that, we discussed about the rules and regulations. So based on the rules, we implemented the program also. We executed. Finally, we seen that how the Tower of Hanoi is working. So this we are end of this video. So now we know that how the Tower of Hanoi is working. Based on that, we have to demonstrate how the disks are moving from one tower to another tower. For that, you can write the program. So now we are in end of this lecture. We have to revisit the lecture outcome. Having completed the discussion on applications of Tower of Hanoi concept, now students should be able to develop a C program to develop map traversal. Okay, so we know that graph traversal, Google map is there, no? From one city to another city, how you are moving from source to destination. That you can use stack concept as well as backtracking concept, perform those operations in the real time. If you have doubt, you can refer chapter 7.7.4 regression in reference textbook Rimathareja. And even if you have doubt, you can watch the weekly tutorial sheet. Thank you very much for listening this video for full concentration. Thank you once again.